In question number 3, we have to calculate the mass of the salt which is required to prepare the solution with this molarity, and given volume is this. Like, we have to calculate how much potassium hydroxide is required if we want to prepare 0.5 molar solution of potassium hydroxide with a volume of 250 centimeter cube. So the formula which we are going to use is molarity is equal to mass of solute and the molar mass of solute into volume of solution. We know that the number of moles is mass of solute. When we divide it by molar mass of solute, then we get the number of moles. So basically the formula is molarity is equal to number of moles of solute divided by the volume of solution in dm cube. But as we are to calculate the mass of solute, so we are opening the formula of moles, which is mass of solute over molar mass of solute. So then the quantity which we need to calculate, we are going to put it here on one side of the equal, and molarity will be multiplied with the molar mass of solute into volume of solution in dm cube. So what we are going to do is to calculate the molar mass of solute. In the first question, the molar mass of solute, they have to ask us is potassium hydroxide. So how to calculate it? In the periodic table, if you see, the atomic mass of potassium is 39, oxygen is 16. They have also given that in the question. See here, potassium is 39, sodium is 23, sulfur is 32, oxygen is 16, hydrogen is 1. So whatever the compound, ionic compound they have asked us to prepare the solutions of, they have given us the MR. So to calculate the molar mass, we are going to add up these numbers. Potassium 39, oxygen 16, hydrogen 1, so that comes out to be 56. The volume they have given us in 250 centimeter cube, so to convert it in dm cube, we are going to divide it with 1000. So the volume of solution is 0.25 dm cube. If I am going to put it here, the mass of solute will calculate, molarity is 0.5 as given in the question, and then mass of solute divided by 56, which is the molar mass which we have just calculated, and multiplied with 0.25, which is the volume of solution. Multiplying these numbers, the mass of potassium hydroxide comes out to be 7 grams. So it means if we need to calculate the molarity of mass of the solute, then we are going to multiply these three numbers. So this is how it's going to work. I'm going to go back to the questions to see the second part. 600 centimeter cube of sodium nitrate solution we have to prepare of 0.25 molarity. So I'm not going to scroll down. You try the question yourself and then play the video and then watch it whether you have done it correctly or not. So yeah, if you have done, I'm going to go down to see what's the answer and check it if your answer is correct. So the same formula which we are using is molarity is equal to number of moles divided by volume of solution in dm cube, as the number of moles is mass of solute or molar mass of solute. So mass of solute we need to calculate. We are again going to multiply these three numbers. I'm sorry. These three numbers. So here we were. We're going to calculate these three numbers. Here we were. Okay. So to calculate the molar mass of solute, we are going to add up these three numbers, the MR of atomic mass of sodium, nitrogen and oxygen. Sodium is 23. It's given in the question. If not, then you must remember it. Nitrogen is 14 and oxygen is 16. As there are 3 atoms of oxygen, we are going to multiply it with 3. So the answer comes out to be 85. So what we are going to do, we are going to multiply 85 with the, again converting centimeter cube 2000. So 0.6, and here it comes. The answer will be 12.75 grams. So similarly we are going to do the third part. Molarity is equal to mass of solute, molar mass of solute, volume of solution in dm cube. The steps are first to convert the volume of cm cube to dm cube, then to calculate the MR. Sodium is 2. Here's 2 atoms of sodium, so multiply 23 with 2. And then 32 is the MR of sulfur. And oxygen is 16 multiplied by atomic mass of, is 4. So solving this part, we are going to get 142, and the answer comes out to be, here we go, 113.6 grams. So this is how the 3 parts are going to be very similar. If you understand one part, then you can try the other 2 parts and then scroll down, or then watch the next part of the video and then check your answers. Now the next part, the question number 4 is again the same. What will be the molarity? So now we know molarity is equal to mass of solute over molar mass of solute multiply volume of solution in dm cube. So this time they have given us the grams of solute and the volume of solution. So we have to calculate the molarity. Formula will stay same, but for molarity calculation, we are going to divide all these 3 numbers. Like the mass of solute is 25, because here mass of NaCl is 20 grams, so it should be 20 here, not 25. So mistakenly they have written 25 here. So never mind, we know that what data we are given with. So mass of solute is 20 grams, we are going to write 20 here. And then the molar mass of solute calculating NaCl is 58.5, as sodium is 23, chlorine is 35.5, comes out to be 58.5. And again the volume of solution in cm cube they have given us here, as you see in the question. So divided by 1000, and the answer comes out to be 0.4. Dividing these 2 numbers, you will get this 0.85. So please never mind this 25. Here should be 20. So they have done mistakenly. Okay, question number 5 is, we desire to prepare 1000 centimeter cube of 0.4 molar solution. So now we know that 1000 centimeter cube is the volume of solution. Capital M stands for molarity. MgCl2 is given, like it's the ionic compound. How much MgCl2 is needed? So this is again similar to that of question number 3, the 3 parts we have done. So formula will stay same, even the method will stay same. Volume in centimeter cube is converted to dm cube by dividing 1000 by dividing it with 1000. Then the mass of magnesium chloride is magnesium 24, chlorine 35.5, 2 atoms of chlorine. So multiplying it, adding it, and this is simple maths. So basically all the questions are using only 2 types of formulas. So it's not very difficult. If you practice it, then you know you can do it. So molarity is 0.4. Again, mass of solute we need to calculate. So we are going to multiply these 3 numbers. Answer comes out to be 3.8. Now the next question is a bit different question, where we are going to do the, titration. 12 molar H2SO4 solution is available in the laboratory. We need only 500 centimeter cube of 0.1 molar solution. How it will be prepared? So this is how the dilution of solution work. The topic is the dilution of solution. The formula is M1V1 is equal to M2V2. So let's go down and see. We need to calculate the volume V1, and what we are given with is, let me explain you. The first molarity given is 12 molar. We have to move to the molarity 0.1 molar. We are given with 12 molar solution, but we need to convert it to 0.1 molar. So M1 is 12 molar and M2 will be 0.1 molar. And the volume of solution which is required is this. So how much volume of this molarity we can use? So V1 basically we need to calculate. It's very simple. Concentration required and given. So concentration given and concentration required, we're going to write like this way, or you can write concentrated solution, dilute solution. M1, V1 represent concentrated solution of the given molarity solution, and M2, V2 represent the dilute solution or the solution which we need to make. So 12 multiplied by V1 is equal to 0.1 into 500 as the data is given. So Again, you can go back to the question and look at the values they have given. Volume V1 we need to calculate. So dividing, doing the simple maths, we are going to get this answer 4.16. So that means if we are taking out of this, out of this much, we take 4.16 molar concentration of 12. So whatever is given, we are going to take out of that 4.16 only, and then putting it in the graduated pipette and put it in the measuring flask. So measuring flask is basically we are using it to prepare the solution. Out of this given molarity, you will take 4.16, put it in the measuring flask, and then making the volume up to 500 centimeter cube. See, add up to 500 centimeter cube, and then we are going to get the desired molarity solution, which was 0.1. So this was all about, yes, all the 6 numericals are done. I hope this is going to help you. Those who have already done, they can check their questions, or and if they haven't done because they didn't understand, they can watch this video and learn. Thank you so much. I'll see you again. Take care.